In this video, I'd like to explain the concept of average value of a function. Typically, what you do with the average value of a function, you start with a formula. It says that your average value, which is going to be the average y value, is equal to 1 over b minus a, where these are your boundaries, the integral from a to b of your function with respect to x. So when we look at this as the average y value, I'm just going to call it y bar for the lack of better terminology, it's basically saying if you were considering a function like water that's very fluid, and that water was in a state where it was shaken up, something like this, at some point it's going to settle back down. As it settles back down, it would form a horizontal line. That horizontal line would be what you call your average value of the function. That's your y value. It's where that all stabilizes. And this formula is what allows us to find that average value, where this is pulled tight, where all the water settles back down, and this would be the water level where it hasn't been shaken up. And so I'd like to do an example of this just to show how this is working. In my calculator, I have a function. My function says 1/4 x cubed minus 2x squared minus 5x plus 8. And I'll show the graph here real quick. There's the graph of this. Now I did a special scale to fit this on the calculator beforehand, but I want to go back to this. I'm simply going to do the integral of 1/4 x cubed minus 2x squared minus 5x plus 8 with respect to x. So I do my dx. Now I need a starting and ending point, and we're just going to arbitrarily make this. Let's go from like -3 to, I don't know, 8. Now if I want to find the average value of this function, the average y value, I would have to apply this formula, which is telling me to go 1 over b minus a, and then integrate from a to b the function with respect to x. So I'm going to do my 1 over b is 8 minus -3, and that would give me that average value of the function. And so I get 1/11. Now I'm going to let my calculator do all this work for me, and I'll show you how we can have the calculator do this. I simply go to second calc, to that calc menu. I'm looking at option 7 there where it says to integrate, and it'll ask what is the lower limit and what is the upper limit. Limits and boundaries are the same in this sense. So I'm going to start at -3, and I want to finish at 8. And you notice how that shades that in. When I look at my calculator, it's given me a value of -157.8958. So this would be 1/11 times -157.8958. I go home, I'll take that value, -157.8958, and I divide by 11, which gives me a value. It tells me that the average value of the function would be located at -14.354. And off of that graph, what that's showing is that average value here. I can even put another function on here. I'm just going to make a linear function, horizontal line, -14.354, and I'll graph that. That's showing that in this blue region, if I was to balance that all out, I could make a rectangle that would go from here to there, and that would be a solid rectangle that goes right along all of this right here. And that would be the average value of my function. So I'll go ahead and just color on my calculator. I wouldn't recommend you guys doing that. But that would be the state of equilibrium, so to speak. And it would be this red line. I don't know if you can see that so well on the video, but that's the average value of the function. You take all that blue stuff and that's where it would balance out at. That's the concept of an average value of a function. Once again, the formula is simply 1 over b minus a, the integral from a to b of your function with respect to x.